Meet Pete. Pete doesn't know it yet, but in 3 hours and 41 minutes at 7:43 a.m., he will be rushing his pregnant wife Abby to the hospital. He won't be thinking about whether his car is charged and able to safely cover the distance from here to there, because the engineers who designed and built Pete's car already thought all about it. SAE International assembled a team of engineers from all over the world to think systematically about the charging of Pete's car. These engineers developed a series of standards that made mass production of Pete's car safe, affordable, and environmentally sustainable. But Pete won't have to think about any of that. He's probably never even heard of us. And we're fine with that. Because in helping the engineers keep Pete's car fully charged and safe, we've done our job. Sleep well, Pete.
Welcome to the SAE event of this everyone. Connectivity is key to advancing safety for everyone sharing the road. I'm Hideki Hada from Toyota Motor North America. I'm an executive engineer at the Advanced Mobility Division. So today we have great speakers from Honda Research Institute, Sue and Esan, to share those V2X and advancing safety topics. But prior to going to their presentation, let me remind you some administrative issues. The first one, I think you may have noticed already that you are all muted and no videos. Please keep in this way. Please don't try to unmute yourself or show videos because that may disturb the presenters' presentations. And also, this event will be recorded and then later available on SA Detroit section's YouTube video for later to watch. So that's even though you had to miss some part of the presentation, you can again come back to the SA Detroit section's YouTube site. Then I think link will be sent by the organizers sometime soon. Then also, the bottom of this Zoom meeting, you should see chat icon, like those like call out icon. So there you can ask questions to event organizers about some administrative issues, and also please use that chat box to send questions to presenters. Then this meeting is this event is 1 hour, about 30 to 40 minutes. Esa and Sue make presentations. After that, we will try to address those questions, as many as possible. They end at 1. Then, yeah, I think then let me transition to actual presentation by Sue and Esan. Then Sue Bai is a chief engineer in Honda Research Institute, and also Dr. Esan Moradi Pari. He is also a research. Sorry, I can't remember the exact title, but the lead researcher in Honda Research Institute. So they both work on the V2X and the various safety aspects, and not only on research on paper, but they work on actual vehicles and technologies, and working with state DOT and other private partners. Then let's transition to Sue and Esan's presentation.
All right, thank you, Hada-san, for the introduction. I am going to share a deck of slides, and bear with me. Let me know if you can see and hear me well. Oh, I need to click window again, bear with me. I think the audio sharing is by default off. Okay, can you hear and see my slides?
Yes.
All right. So Honda and Toyota has been one of the earliest, two of the earliest OEMs to start this V2X connectivity, safety, communication research, along with many other major automakers. And this activity certainly wouldn't happen without the OEM's collaboration. So before we start to talk about Honda's work, I do want to take the opportunity to thank Toyota and other OEMs for the early contribution that have pushed the technology to this far. So we will talk about our objective of a pilot deployment in various places and our thoughts of where the technology is evolving and what industry has learned and are moving towards. So this is Honda's safety technology roadmap. As you can see, we started the ACCs and the collision mitigation braking system. Around 2020, we started investigating, around this, like mid-2000, we started investigating vehicle to infrastructure. We're thinking at some point between 2020 to 2030, there would be some form of a deployment of a connected vehicle technology to enhance transportation safety. The Smart Mobility Corridor project is part of a larger project that's awarded by US DOT in 2016. Some of you may have heard Smart Columbus, and this corridor is a sister program to extend the Columbus area's connected vehicle environment build towards Honda's facility, where we're using the Honda Commuting Associates vehicle retrofitted with the V2X technology to assess the safety benefit in a relatively high density environment, considering how many people are commuting every day. So this, in the beginning, there is a smart mobility in Columbus, and there's some stations set up. In 3 years, we built not only vehicles, but also intersections that has the video streaming capability to show the non-line of sight traffic view to the user, even though their view physically may be obstructed by other vehicles. And we'll talk about the smart intersections that we think would be one of the solutions to help generate the high density environment without counting on all the vehicles having the technology on board. And through our objective, through number of vehicles and the data collections, we are hoping to find out how the vehicles interact with each other, how long, what's the quality of the connectivity, so that we can design our future connected vehicle system more effectively. So this chart, for example, is one of many data points to tell us if there are two vehicles happen to be talking to each other, they typically talk at least 5-10 seconds. Sometimes it can last till minutes. And this we consider a good data to show that if they were to communicate safety critical information, there's enough time for the driver to realize they have someone they're communicating with, and they can have a meaningful engagement during that time frame. And some of the example of when we first had 5 vehicles in 2017, gradually increased the number of vehicles to about 200 2 years ago, and we are covering a very almost like a full coverage in Northwest Columbus area. So this is a video that I am about to show. Oh, just a second. I think I set an alarm. Just a second. My apologies. Here's a video that you can find on YouTube to explain what the Smart Mobility Corridor implementation look like.
Honda continues to research connected safety technologies that have the potential to help reduce collisions and save lives. Honda's Safe Swarm technology, using Vehicle-to-Everything or V2X communication, allows vehicles to communicate with other road users and share key information such as location and speed. Honda is conducting real-world testing of its Safe Swarm technology as part of the Smart Mobility Corridor program on US Route 33 in Ohio. More than 200 vehicles have been retrofitted with equipment needed to participate in the program, including antennas to navigate and broadcast information, an embedded computing device to interpret and communicate data, head-up display and speaker providing information with visual and audio alerts to the driver. Based on this system, Honda is testing a number of connected safety applications. Situational awareness. As a vehicle enters the smart mobility corridor, the head-up display informs the driver that other connected vehicles are also on the road. The situational awareness application displays the relative position of other connected vehicles and connected pedestrians near the driver. Signal countdown timer. As a vehicle approaches a connected intersection, the driver receives a red light countdown, allowing the driver to adjust the vehicle speed to cross the intersection when the traffic signal turns green. Maintaining a steady speed with fewer stops can improve energy efficiency. Lane speed monitoring. On the smart mobility corridor, the network of connected vehicles is mapped to indicate the traffic flow for each lane. The lane speed monitor allows the driver to select the lane with the least congestion, saving some time and energy. Sudden braking alert. An obstacle on the road causes drivers to begin hard braking to avoid a collision. Connected vehicles closest to the obstacle communicate a warning to approaching vehicles, allowing them to slow down gradually and reduce the potential for a collision with other vehicles. All connected vehicles within the communication range receive the alert with no direct line of sight needed. As part of the Smart Mobility Corridor activities, Honda continues to expand the capabilities of the Vehicle-to-Everything V2X communication to other applications. Honda Parking Finder. As the Honda connected vehicle passes through the guard shack, the Parking Finder application provides information about the parking layout.
Hard parking.
As the vehicle gets closer to the parking, it recommends an available parking lane closer to the building entrance.
Available spots in lane 7, proceed to parking lot and then keep left.
Once in the parking lanes, more detailed availability to the left and right is communicated. The Parking Finder application sends updated parking availability every 30 seconds. With this information, connected vehicle drivers may save time and more efficiently find available parking. Extra vehicle-to-vehicle applications. Some additional safety applications in Honda connected vehicles are control loss warning, emergency vehicle approaching, oncoming cross-traffic warning, and weather and speed information. As part of the Smart Mobility Corridor, Marysville, Ohio's 5th and main intersection is equipped with a smart infrastructure based on cameras detecting vehicles and pedestrians.
For this one, we have more detailed video in the later part of the program. So I will exit from this video and move to the next segment.
And sending this information to all connected vehicles. Thanks to this
Just a sec. All right. So through this almost 3 years of a fleet operation, all those combined mile of travel exceeded 1 million miles. And we've had many vehicle interactions talking to each other. And the warning generated is a good indication of the safety benefit that's already here. The smart intersections certainly helped some of these interactions by enabling non-equipped vehicles to communicate with equipped vehicles through infrastructure's help. The signal phase and timing is one of the most popular features. And people keep coming to us saying, oh, when can I have this in the car? One of the immediate benefit we have investigated is in the video, you might remember the situation where in the lane speed monitor, where even within 10% of a vehicle connected, there is a capability to assess the upcoming lane level speed assessment, and then the vehicle can make a judgment whether it's time to change to a faster lane. Doing that would help the average speed improvement to up to 10%, and without having every car connected to each other. And next, I'll hand over to Esan, who's our lead scientist, and he is really the one behind the scene implementing I would consider the world first smart intersection that has a very sophisticated capability. Ehsan, go ahead.
Thanks, Sue. Hi, everyone. This is Ehsan Moradi-Perry. I'm the lead scientist of Honda Research Institute. Yes, Honda Smart Intersection. But before we jump to the solution, I would like to explain what was done explain what was done. I would like to introduce the research questions we had and to share our line of thought. We had 3 research questions in front of us. How to increase safety benefit in early deployment where there are not many V2X equipped road users. How to evaluate V2X applications in real world, not only in simulation. For that, we needed to create the environment. And how to deal with mixed traffic where some route users are equipped, some are not equipped, and how to handle such scenarios. And that's why we came up with this smart intersection concept. I think we will share a video first because video explains better than me, and then I continue after that.
Fifth and main intersection is equipped with a smart infrastructure based on cameras detecting vehicles and pedestrians and sending this information to all connected vehicles. Thanks to this smart infrastructure, connected vehicles are able to receive cautionary information about red light runners crossing the intersection ahead, emergency vehicles approaching the intersection, pedestrians on crosswalks, and signal countdown information to assist drivers when it is unsafe to enter the intersection. Smart work in progress. At the Honda
All right, so that's a very brief view of the smart intersection. We'll skip the longer version of the video for now. And then Ehsan, go ahead.
Sure. As you realize, this smart intersection concept, it had 2 components. One was the smart infrastructure, and one was connected vehicles. The reason why we call the infrastructure smart is that usually the V2X infrastructure, it has traffic information as well as a radio to broadcast that traffic information. But this one, we needed to add more to it because we needed to detect non-connected objects and be able to differentiate the type of objects and then give that information to the radio to broadcast that over there to the cars and other road users. So the object detection, we implemented it through cameras as well as a state-of-the-art deep learning solution for object detection. And we utilized RSUs to send messages regarding those detected objects as well as traffic information. And these messages were received by connected vehicles and were utilized by connected vehicles to warn the driver, if necessary, about the potential collision situations that might come up, or to increase the driver's awareness about the intersection and the objects at the intersection. Next, please. So yeah, here is the location where we implemented it. It's at intersection in 5th and Main in Marysville, Ohio. The 4 red circles show where the cameras were mounted, as well as the RSU on the right side, and the algorithm or the deep learning solution that we had, and the equipment for that, which we call it IPU. This is located in the traffic cabinet at the intersection. Next, please. So I want to repeat it, the goal was to create a high density to answer those 3 research questions. And this high density, we targeted a high accident location, which for us, I think everyone knows the importance of intersection safety, and the fact that this intersection safety might not be, we might not be able to provide such safety to customers through other sensors, because and the other solution might not be practical because the for crash prevention due to the obstructed view by buildings and other road users and objects. That's why we targeted this scenario, and we first targeted pedestrian safety, public safety through emergency vehicles such as police or first responders, if I want to put it that way, and vehicle safety at the end. And we created this high connectivity and high density environment under different challenging weather and traffic conditions, days and nights, rain, snow, foggy, and we were able to deliver a very stable solution for object detection and broadcast at the intersection. Next. We also implemented the same solution at another location. This is close to Honda facility in Ohio. It's in Raymond, Ohio. We implemented a similar feature. There was a intersection type where the drivers get off of the highway, and when they want to go toward the facility, there is a intersection, a stop sign type intersection, where the view is usually blocked by trucks and other road users, and it's triggered. So we implemented the same solution. This time it's only one camera because it's only one direction heading toward that intersection, and we mounted RCUs as well as the image processing unit in the cabinet there to deliver same feature and provide the awareness about the vehicle traveling on the bridge coming toward that intersecting point. Next, please. And this was the type of application provided. If you look at like the motorcycle rider is driving, it's sometimes the motorcycle is behind another car, and there is no way for the driver who wants to make the right turn and go toward the facility to realize the existence of motorcycle on the road. So we utilize such feature, and we provide that awareness through the HMI design. Could be rear view mirror or heads-up display or other HMI solutions, and we provide that information to drivers to know that there is a motorcycle coming, even though the view of driver is obstructed by a truck or other road users.
So we also worked with Toyota and other manufacturers to participate in a US DOT-funded connected vehicle pilot program in Tampa, Florida. We have worked directly with the local Honda and Acura dealers so that they take care of the connected vehicle retrofit installation and customer service. We have a great relationship and a very friendly experience with the dealership support and the direct customer interaction. This gives us a preview of in the future, if this system needs to be installed after the vehicle is sold, now we know there is a way to get these in. And the picture shows some of the installation process happened last year at the dealer's very nicely equipped garage. Ehsan, go ahead.
Sure. Here, I would like to introduce our 5G V2X research. So this research was done in collaboration with first we Sue, you want, or I can go.
Sorry, yeah, I flipped it too quickly. Ehsan is trying to make it aware that Verizon Wireless has been a great collaborator with Honda to explore the 5G mobile edge computing side of the V2X implementation? Esan, go ahead.
I think everyone is aware of like the spectrum challenges for V2X and at 5.9 gigahertz. I think FCC reopened the 5.9 gigahertz to share with unlicensed Wi-Fi. We originally had 75 megahertz for V2X, but with the reallocation, the portion of the spectrum was reallocated for Wi-Fi, and the V2X has 30 megahertz spectrum. But as we mentioned, many use cases for V2X safety, such as pedestrian cars, emergency vehicles, and first responders, and other use cases such as the mobility-related use cases such as cooperative cruise control or platooning, and those we believe we need more than 10 megahertz channel, which is 30 megahertz channel. So spectrum is key, and to be able to deliver more safety features, we need more spectrum for V2X. Next, please. I would like to introduce the Verizon 5G V2X related research that we had. So the goal for us was to improve safety, leveraging the 5G and MEC, which stands for multi-access edge computing or mobile edge computing, same thing. But so if I want to provide you a background, is that V2X communication, our understanding is that the V2X direct communication is currently uncertain in US for various reasons. So because of that, also aside from deployment challenges, the safety benefit is limited early days because of the many unequipped road users, existing users, that Smart Intersection was trying to address the same questions. So the solution we had was to leverage 5G MEC to fill the gap and help us to realize more safety benefits, and we leverage the existing network deployment to deliver safety features. Of course, everything what we did, everything is connected through network, and we leverage the same V2X messages that are known to the community, and it's just the interface is different. But this solution also has its own challenges that it requires more research and effort to tackle them. Some of them, like limited coverage. Everyone is aware of that. Even if you drive, I think, from Pittsburgh, Pennsylvania to Washington, D.C., the capital, there is still a stretch of the road that connectivity is limited. So limited coverage everywhere is one challenge that needs to be improved. Also, MEC deployment and optimization of MEC to deliver mission critical applications. Also another question that I know telecommunication industry is working hard to address that. The carrier handoff strategies for multiple carriers scenarios, I think that's also a key challenging that telecommunication industry is currently working on that to answer that. One key thing is the local and regional government trust establishment on new technology, because these are new technologies for them. How to work with them to build the trust on the new technology is also key. And also OEM telecommunication or carrier providers, as well as road operator ecosystem. I think that's something that needs to be improved to realize the benefit from network for safety. Here we have a video of this collaboration.
Honda and Verizon have teamed up to research new connected safety technology that has the potential to reduce collisions and save lives. Since 2017, Honda has been developing safe swarm technology to realize a collision-free society. Using vehicle-to-everything V2X communication, Honda's Safe Swarm could enable vehicles to communicate with other road users and share key information such as location and speed. Now, Honda is collaborating with Verizon to research the use of 5G technology for connected and autonomous vehicles. 5G wireless technology has the potential to ensure fast, reliable communication among vehicles, road infrastructure, pedestrians, and motorcycles. 5G technology allows auto OEMs to move the artificial intelligence from the vehicle to the mobile edge compute (MEC), reducing the need for AI on board each vehicle. Honda and Verizon recently demonstrated their joint safety research at MCity, a connected and autonomous test facility in Ann Arbor, Michigan. Superfast data transmission is essential for connected vehicle safety. Using Verizon's 5G ultra-wideband, mobile edge computing, and the V2X software platform, Honda and Verizon demonstrated 3 safety scenarios. A pedestrian is crossing the street at an intersection. An approaching driver cannot see the pedestrian due to a building obstructing the view. Smart cameras mounted in the intersection relay information to MEC using the 5G network. MEC detects the pedestrian and vehicle, determines the precise location of road users, and sends a warning message alerting the driver of the potential danger. A driver cannot see an approaching emergency vehicle and cannot hear its siren due to the high volume of in-vehicle audio. MEC receives a safety message from the emergency vehicle and sends a warning message to nearby vehicles. The driver receives a visual warning. A vehicle fails to stop at a red light. Using data from the smart cameras, MEC detects the vehicle and sends a red light runner warning message to other vehicles approaching the intersection. These safety scenarios demonstrate the potential of fast, reliable 5G to communicate urgent safety messages between vehicles and infrastructure, reducing the need for complex computing on board each connected vehicle. In the future, connected vehicle technology can help ensure that autonomous vehicles will be able to communicate seamlessly. Honda and Verizon hope their research collaboration will reduce collisions and save lives.
Yes, as the video was explaining, I think there are 2 key components of this 5G V2X solutions. One is the network, and the other one is the computation that could be reduced from the car. We further expanded the computation part of it and looked at other use cases such as perception sharing, which they require more computation. We tried 2 different solutions. One is where the car detects the objects and sends the objects to the network, and network brought unicast that to relevant road users. And the other one was the car provide the sensor information. This could be car, this could be infrastructure, camera mounted at intersection, and other solutions. So it doesn't have to go from car. I think data and sensor data is important, and it could be provided to network and MEC through various sources. And MEC would would process the data and send the object level information to road users. I think looking at this, one question you might have would be the latency. Would that latency meet the automotive requirement and automotive applications or not? If you click on it. So we further investigated that and analyzed the latency requirements. For us, LiDAR data going from car to MEC, it took 60 milliseconds based on various tests we had, and that it's 60 milliseconds is mainly to upload the data. And for MEC to send back the processed information to car, it's 10 milliseconds delay. The data processing part at MEC, it takes it takes some time as well, but per the computation capability of MEC, it could vary, but based on our testing, that could take another 90 milliseconds to 120 milliseconds. So overall, 170 to 200 milliseconds for the end-to-end data upload, process, and object information delivery to the car, which meets the requirement that we have. Next, please.
Go ahead, Esa.
So as a summary, I think Honda, we believe Honda is committed to advanced V2X research, safety research, pilot deployment, and collaborating with other stakeholders. As you realize, we collaborated with many stakeholders and from private and public partners. We are seeking new innovative solutions such as the smart intersection that we showed, and also the 5G V2X solution. And we would like to evolve technologies. Also, let's work together to improve safety, transportation safety, and people's life, hopefully.
Right, that's all the presentation we have. Now the floor is open for questions.
Yeah, thank you, Sue and Esan, for the nice presentation. And people who are attending this event, please use the chat box function on the bottom to ask questions to Esan and Sue. Then while you're typing, I have some questions for you. That the automotive industry, like us, we say safety is a priority. The infrastructure industry, they say safety is priority. But traditionally, we have not talked to each other. I think V2X enable us to talk to each other, but based on your experience working with those people in Ohio, Florida, some of the infrastructure side people, what was the biggest benefit of talking to them or discovery of your interaction with those state DOT or infrastructure owners?
Well, I think for us, the biggest benefit is to realize that we have a common goal, whether it's a state DOT or local city. We all want to make the road safer for the local residents and other travelers. And without infrastructure, just counting on vehicles communicating to each other could take decades to realize some safety benefit. By working together, for example, that smart intersection implementation that Esan led can make an intersection immediately fully connected as if there is a 100% density of a connected vehicle. Working together can create a future much quicker.
Anything for Esan?
No, I think Sue answered that. It's just lesson learned from each other. That's key.
Also, my question also related to similar aspect, but different dimensions. That even internally, when we talk to people who work on fully automated vehicles, they often say, we don't need communication. We have great onboard sensors. I don't think so. But how was when you interact with those people, how do you see the benefit for those fully automated vehicles using V2X type communication?
Well, my understanding of one of the V2X benefit is to have a much clearer understanding of road users' intention and their projected path. This makes the travel much more efficient. If we don't have that level of a communication, I can see the fully automated vehicles can behave very conservatively. And this potentially leads to a very slow moving traffic. But with communication, the intention sharing, the maneuver sharing would allow much more efficient movement. And like Esan is working with Verizon on the raw sensor data sharing, those are, we're not talking about future technology. The technology is already here. if we apply these technologies timely, we can have these benefits that provide a further enhancement to fully automated features as well.
Actually, I forgot mentioning about this. Both Esan and Sue are significant contributors to SAE standards for V2X issues. So again, thank you for creating the nice foundation. That's why we can talk to each other, and so talking with those like infrastructure and different stakeholders. So my last question is actually a technical thing that when we look at those infrastructure-based sensing of a vehicle, as you know, in the V2X, we had to send on the V2X signal, we had to send the center of a vehicle as a location. But when you use a camera on a signal pole or something, we may only see the front or a little bit of side of the vehicle. Then are we communicating the same location?
Wow, Esan has researched this for months to solve this problem.
So yeah, that's correct. In V2X, when we send a message, we send the center, but we have the vehicle length and width also in the message that we can that the receiver side can determine where the front and back of the cars. But for this one, as you mentioned, we detect the front bumper and windshield, but our deep learning solution, our AI solution, it has the object differentiation. So we can tell if it is a truck, if it is a motorcycle, if it is a sedan, or if it is a SUV. And we came up with algorithm to further, after differentiating the object type, then we move the front detected information to the center of the vehicle, and then also provide the vehicle a typical average length and width for that class of car or object.
Thank you. Then let me read some questions from the audience. Then the first one is when you see an object on the road, the detection by one car and transmitting that one to another car. So the performance of object detection depends on the weather condition and visibility. Then what's the biggest challenge on that area? And also related question is how far can the signal can be transmitted?
Oh, the signal can be transmitted far enough. That couldn't be an issue, because V2X, I think 300 meter guaranteed, even for infrastructure, since it is mounted on top. I think the range is better. But if you look at the object detection challenges for different weather conditions, that's true. Some weather conditions might affect the detection, but this could be tackled and in two ways. One is having a good deep learning and trained algorithm for object detection. The other one is having a robust application design at the vehicle side, which we had both. And we published the result for different weather conditions recently at IEEE. I think IEEE Intelligent Transportation System magazine. And in that paper, we have shared the result and robustness of the detections in various weather conditions.
Another question is that security of communication has been always a topic for V2X, also the network-based. Then can you address how those protection for security protection and protection against cybersecurity? So can you mention? We can spend hours talking about this one, but can you touch how basic security is implemented in this V2X or your work with Verizon?
I think same security solution. Also, carriers, they usually have different layers of security protection as well. But many of the V2X already, the V2X direct communication security work could also be utilized again. What I try to say is that we do not need to reinvent the wheel. We are just learning from the existing work, and we implement it differently. So I don't think the technological aspects is the barrier here. I think the solutions is there.
Then the other questions are actually common one, the difference between DSLC and CV2X. They said that before asking the question to you, like I also have to mention that CV2X, the usage of the word has to be really careful. That it can include like Verizon type, like cellular communication. It can be LTE type direct communication. It can be 5G based new radio V2X communication. But when we talk about the particular FCC type discussion, the LTE based V2X and DSLC, then do you have any comments about that one? Sorry, we are entire industry waiting for the answer from Washington DC on this issue.
Issa, go ahead.
Yes, I think as Honda, we are technology neutral, and we have to remember that the chipset or the technology being used is secondary. The first thing is application and safety, and how to realize that through various technologies. We understand that, but we would like to mention first is safety, application, and not technology.
And if I could add a little on the Verizon solutions, there we have worked together with Verizon and using MCity as one of the very first site, if not first in the US, maybe first in the world, to have such a sophisticated capability. That is also referenced as a CV2X, but that is not LTE direct communication. It is next generation 5G mobile edge computing. So the term, often people use CV2X. I'd say if we draw a percentage, 80% of people are probably thinking of LTE V2X direct communication, not the next generation 5G version. We, as a researcher, when we started explaining this to people, we can see people's eyes started getting blinking. Well, what are you talking about? So that's, I think I'm glad someone asked, but there's no short version of explaining what technology is which. Again, as Ehsan said, we're focusing on application, and we're very glad to work with Verizon to explore the true next generation capabilities.
Another question, my interpretation may not be perfectly accurate as what person asked, but let me ask this question this way: so the V2X and V2 network, the mobile edge and those communications that enable many new safety applications and or enhance the existing capability of safety devices. So but I think you introduced those safety swarm concept and applications. Then how it can be really enhanced beyond that, and also by having those communication, will that change the requirements for the existing safety systems on the car?
Well, I often compare these approaches to healthcare. I consider the V2X mid to long range situational awareness as the preventative care in healthcare, versus ABS and airbags are more of a close to emergency hospital treatment. If we can exchange intentions and awareness much earlier timing, such as 5 or 10 seconds before, then we could eliminate the potential of a threat being developed. Then the crash would not even happen. Versus if we don't have that communication and rely on onboard system only, that's when we often had to wait till the last minute to take a very extreme intervention and vehicle control countermeasure. For example, the 5G MAC or smart intersections give the infrastructure the power to paint the picture of a bird's eye view of a surrounding traffic situation. And each vehicle can take that environment and assess the relevance to themselves, whether the car is 1 or 2 cars ahead or some other angles that their onboard sensor wouldn't cover. In that case, for example, the vehicle may be thinking of switching to a different lane, but then knowing that lane may slow down, the vehicle would abandon that lane switching. And lane switching is one of the causes of a vehicle collision. So that collision potential would be eliminated before it actually becoming a potential.
Also, another aspect that, so you ask your colleagues in Ohio plants or somewhere around there that use those V2X devices while they're commuting. Sorry, I believe they are safe drivers, but what were their general impression from them? Like, they liked it? I think it looks like, I didn't know about this parking application, but I'm sure they liked that one too.
Oh yeah, they like that one. And Hassan is the engineer who led the earlier phase of deployment. We have a group dedicated in Ohio to continue maintain the fleet. Our understanding of the user feedback is the signal countdown timing is one of the most popular features. I think that's another great benefit of having an infrastructure involvement. These additional information transmitted to the drivers early that reduce drivers' anxiety and make their driving experience much more pleasant. And that could lead to less collision, less road rage. And I would like also take this opportunity to tell a very short story. One of the engineers came to us, a very seasoned engineers. He said, we understand that there is only limited number of cars to communicate with. I'm not counting on this V2X safety to work every day, every time, but I am thrilled to show the system to my son and daughters when they're still grade school age children to tell them what the future looks like. I think that's a great benefit that should not be overlooked, even though these pilot programs have a limited scope and limited coverage. Without these piloting, the technology wouldn't be developed as far as we can see today. And I also want to acknowledge that Toyota team and John Kenny and Hada-san, these are well-known people that have done tremendous work to work with us and other automakers, and of course Aaron on the call from Denso, also a significant contributor. This is a system that everyone needs to join to make the full benefit of it.
Yeah, thank you for the comments. And also, actually, it's a great technology, but at the same time, like when I show this one to my friends and the family members, they were also surprised how simple this is. All we need is just an antenna, ECU, and power, basically.
Yeah.
So it's just plug in. Yeah.
Right, and through the dealer retrofit process, we realized that it doesn't take that long to equip the vehicle. And like Ehsan said, the technology is simple and ready. So the deployment now is really not a technology barrier. There are other challenges the industry and the government are trying to resolve.
Okay, only 3 minutes left, and I think we're a little bit early, but I think we covered questions. So therefore, maybe we can finish the Q&A sessions. And before making close, before me making closing, Sue or Esa, any additional comments you want to make at this point?
Oh, I would like to again thank Verizon, thank Toyota, Denso, and many other stakeholders to stick together on this topic, do the best we can to improve transportation safety. Ehsan.
Yes, similar. As Sue mentioned, our partner, as well as I think Ohio DOT, they deserve it. like recognition for our research.
Yeah, thank you very much. And we are coming to the end of the event. And yeah, thank you for all. Thank you for Sue and Esan to make those nice presentations. Thank you for attending the right questions. And those, you can also contact. I think they'll be showing the email address. If you have any questions about additional question about their presentations and any additional question about the SA and Detroit activities, please send emails to these addresses. And also later, I think we will you will receive a link to the YouTube video of this event. And again, thank you again for both Sue and Esan and SA Detroit for this great event. Thank you.
Thank you.
Thank you.
Bye.